In the second part of section 3.8, we'll start with this example. If we're given that radical x plus radical y equals to 7 and y of 25 equals to 4, we want to find y prime 25 by implicit differentiation. Okay, now first of all, remember when we have this terminology, y of something equals to a value, the inside always contains the x, and then the outside always contains the output, which is the same thing as the y value. So this point is going to be the point 25 comma 4. Let's not forget that. And I'll write this at the bottom as well. So we're given y of x equals to, in this case, the outside is going to be the output or the y value. So y of 25 equals 4. The input or the x value is 25 and the output or the y value is 4. So that means our point is going to be 25 comma 4. X is 25, y is 4. Parentheses always contains the input. Okay, now let's use implicit differentiation. So I take d dx of each term. So I take d dx of x to the 1/2, d dx of y to the 1/2, and d dx of 7. Remember, before we can differentiate, the radicals have to be converted into rational exponents. Then I take the derivative with respect to x of all the terms. So for the first one, the input and the term are the same. So the 1/2 is going to come to the front. And remember that if you have 1/2 and you subtract 1 from it, that's 1 is the same thing as 2 over 2. Then this gives you a negative 1/2. So that's the exponent for the x. Same reasoning goes for the y. The 1/2 comes to the front. We subtract 1. We get y to the negative 1/2. However, in this case, because the input and the term are different, we have the dy dx. We're taking the derivative of y with respect to x, and we're always going to have a dy dx in that case. Let's clean this up. We have x to the negative 1/2. We can't have a negative exponent, so that's going to go to the denominator. And remember that if you have x to the 1/2, that's the same thing as saying square root of x, because the exponent's 1 and the root is 2. So that's going to go to the denominator, and we already have a 2 there, so that'll be 2 radical x. Same reasoning goes for the y. We move the y to the negative 1/2 to the denominator, and 1/2 is the same thing as radical y. So we get 1 over 2 radical y, and then we still have the dy dx is equal to 0. Our objective is to solve for the dy dx. So I'm going to take the 1 over 2 radical x and move that to the right by subtracting it. So that goes away. I have 1 over 2 radical y times dy dx is equal to negative 1 over 2 radical x. Now normally we would divide by a fraction, or whatever this term is, but we can't divide by fractions. Instead of dividing by a fraction, to undo that, we have to multiply by its reciprocal. And the reciprocal of 1 over 2 radical y is 2 radical y over 1. And again, I'm doing this because I can't divide by a fraction, so instead I multiply by the reciprocal. So on the left side, everything goes away. And on the right side, the 2's cross cancel. So we're left with a negative radical y over radical x. Okay, now remember, our point is 25 comma 4. The input is 25 and the output is 4. So then what I'm going to do is I'm going to replace the y value with the output, which is 4, and the x value with the input, which is 25. And the dy dx, or the derivative, this gives you negative 2/5. So the derivative at the point 25, 4 is going to be negative 2 comma 5. Next example, we're given y squared plus 6x to the third equals to 7y minus 3x squared. Use implicit differentiation to find dy dx. Now, if we're looking for dy dx, that's going to come from the y terms. So I'm going to take the derivative with respect to x of all 4 of the terms, and I'm going to use the power rule of derivatives to solve this, right? So here the 2 comes down, then I have 2y dy dx. Here the 3 comes down, I have 18x squared. There's nothing left over because the input and the term are the same. Here, the derivative of 7y is 7. There's like an invisible 1. 1 times 7 is 7. The y goes away. But because we have y with respect to x, we have that dy dx. And then here we have 2 times 3, which is going to be a 6x. So now we want to get all the dy dx's on the same side and everything else on the other side. So what I'm going to do is I'm going to subtract the 18x squared. So I have 2y dy dx equals to 7 dy dx minus 6x minus 18x squared, and then move the 7 dy dx to the left. So that's going to give me the following. That's going to give me 2y dy dx minus 7 dy dx equals to negative 6x minus 18x squared. When you have two different terms with the dy dx, we have to factor it out. So if I factor out the dy dx, it's going to give me 2y minus 7 equals to negative 6x minus 18x squared. And then finally, I divide both sides by 2y minus 7, and that's my derivative, 6x minus 18x squared over 2y minus 7. All right, that's it for this lesson. Please come to class with questions, and I look forward to seeing you guys.